So we're going to talk about the discovery of the electron. And if I remember correctly, I found a couple of neat videos on YouTube that pertain to this chapter, and so I will post them to the playlist. And I might think to show them to you during lab, but I might not, and you can always go and look at them at home. So J.J. Thomson, this guy lived back 1800s, 1900s. He was using something called a cathode ray tube. So this is a partially evacuated glass tube, and you apply a high voltage across the tube. It bears some resemblance to a fluorescent light. So we've got some gas in here and a high voltage going across. And what happens is you get a beam of light that passes from one electrode to the other. So a beam of particles called cathode rays went from the negatively charged electrode to the positively charged one. So, you wonder, how do they think these things up? Who thinks to try these things? Creative people. And he found that the particles in this ray had the following properties. They travel in straight lines. They were independent of the composition of the material from which they originate. So he could make tubes where the end was a different material, the cathode was a different material, and the particles in that ray had the same properties regardless of what material it was made out of. And he found that they carry a negative electrical charge. He found that they carried a negative electrical charge because if you apply a field, here's an electric field, you can actually cause that beam to bend, and that tells us that it's charged particles. So he was able to measure the charge to mass ratio of those cathode ray particles, and in case you haven't guessed, those cathode ray particles end up being electrons. He could find the charge to mass ratio by deflecting them using electric and magnetic fields. So here he's got the cathode generating the cathode ray, and then he uses electrically charged plates and magnets to deflect it. And he could measure the deflection of the beam, and based on that, he found that the charge to mass ratio was minus 1.76 times 10 to the third coulombs per gram of particles. And then the slides just abruptly switch to something else. There's got to be more to say about that. This was an important piece of information. He didn't have the charge of a single electron. He didn't have the mass of a single electron. But he was able to figure out the charge to mass ratio. And so this came in to be very handy later. Another experiment was done by Robert Millikan. He was an American physicist, roughly the same era as Thomson. And he did this oil drop experiment. And from this experiment, he was able to figure out the charge of a single electron. So what he did was he had an atomizer that would spray a very, very fine mist of oil particles into this container. And they, of course, would fall because things go down because of gravity. And he had a positively charged plate and a negatively charged plate. And they would fall through little holes in this plate, and they would come down, and he would send ionizing radiation in here, which would cause these little oil droplets to become charged. And then he could adjust the negative and positive charge to get those oil droplets to stay suspended in the air. And that gave him information about the charge on that particular oil droplet. And he has this little viewing microscope in here, so he could look in here and adjust the voltage on these plates until the oil droplets would just suspend. And that gave him information about the charge on the droplet. So he would measure the strength of the electric field required to halt the free fall of the drops. And he could figure out the masses of the drops themselves by measuring their radius and the density, and then he could calculate the charge on each drop. And what he found was, the drops were different sizes, of course, but the measured charge on any drop was always a whole number multiple of minus 1.96 times 10 to the minus 19. So all of these charges on the drops were multiples of this number. And that told him that that was the fundamental lowest charge that was on any of these drops. They were whole number multiples of this particular charge. So that must be then the charge on a single electron. So he figured out the charge on a single electron. Thomson figured out the charge to mass ratio. What can you do with those two numbers? You can figure out the mass of an electron. You can't weigh an electron. You can't even collect electrons, but we can figure it out. So what J.J. Thomson had discovered was the electron. It's negatively charged, and it has a very low mass, and it's present in all atoms. So we do need to have some basic understanding of properties of electrical charge. Opposite charges are going to attract each other. Positive and negative get attracted. Electrical charges behave much like magnetic charges do. The north pole of one magnet and the south pole of another are attracted to each other. But like charges repel each other. You get two north poles or two south poles, and they're going to repel each other. If you've ever played with Brio trains, you know that if you get the car backwards, it not only will not stick to the locomotive, but it will actually get pushed away. If we have positive and negative charges that come together, plus one and minus one, then together this is going to have no charge overall. So charges, we can think of them as canceling, or really they're adding up to zero if they're the same magnitude. So with the charge on the electron and the mass to charge ratio, we can figure out the mass of an electron by taking the charge and multiplying by the mass over the charge, and we can get the mass. Doesn't it seem like the mass should actually be like kind of given right there? Yeah. I need to go back and edit that. We should have the mass there. It's like 10 to the minus 31 kilograms, something like that. I'm sure it's in your book.